Hello students, Professor Gray here. We need to keep on talking about the metric system, and particularly in this lecture, we need to talk about converting between one metric unit into another metric unit. So let's take a look at this chart right here. And this chart is going to show us the base unit in the middle right there. So those are our metric units that don't have any prefix. So that's going to be gram, liter, meter, etc. So there's no prefix, meaning that little part in the beginning of the word right there that changes it ever so slightly, like kilo or giga or milli or centi. Okay, so our base units, the ones with no prefixes right there, this is going to be our standard size. So we're just going to call this 1. And remember, 10 to the 0 power is what? That's 1. So that's why we have the 10 to the 0 power in that column right there. Now, the units, as we go up, these ones are getting larger. And going down, these ones are getting smaller. So that should make sense to you guys that a centimeter is smaller than a meter. Okay, so how do we read this chart? Well, if we look at the base unit, and let's do gram, and we compare it to kilogram, what does the middle part of the chart tell us? Well, if you look up here and we compare gram to kilogram, what this 1,000 right here is saying is that 1 kilogram is 1,000 times bigger than 1 gram. Okay, so that's telling you the size of that unit with that prefix on it. So what this is also telling you is that you can fit 1,000 grams in 1 kilogram. So that's what it's also saying. So how we would write this equivalence statement, it is a little bit interesting because this part of the chart is telling you the size of each unit. But when we go to write the equivalence statement, it seems kind of like it's backwards. But we have to say it out loud in our mind to make sure it makes sense. And what on earth am I talking about? Well, I'll show you right here. So 1 kilogram, that's going to be equivalent to how many grams? How many little small grams can you fit in 1 kilogram? Since the kilogram is the bigger unit, that's 1,000. You can put 1,000 grams into 1 kilogram. That's equal. But what is interesting about the chart here when you look at it is that kilo in this line right here has the number 1,000, and your base unit, your gram, has the number 1, and that looks a little bit opposite there when we're making that equivalence statement. But the thing about this is this column right here is talking about size. So this is saying that the kilogram is 1,000 times bigger than the gram. So it should make sense to you guys that you can fit 1,000 grams in 1 kilogram because the grams are really small. So you need 1,000 of them to make up 1 kilogram. So I know it looks a little bit backwards, but we're talking about different things. So right here, again, it's talking about the size of that. Now, the other way that we could write this statement might be that 1 kilogram is equal to 1 times 10 to the what? 10 to the third grams. And you'll see the 10 to the third up there. But again, that 10 to the third doesn't go with the kilogram here. It seems like it's opposite. It seems strange that the 10 to the third goes on the gram size. But again, this 10 to the third up here is telling us that the kilogram is 1,000 times, 10 to the third is 1,000 times bigger than this guy right here. So you're going to be able to fit 1,000 of these in that one. Okay, so another way that we could write this is we could say that 1 gram is equal to this tiny little portion of a kilogram. So 1 gram is 0.001 kilogram, or 0.001 kilogram, that tiny little bit of the kilogram, is equal to the gram. Another way we could write this is 1 gram is equal to 1 times 10 to the negative third kilogram. At this point, right? But all of these things are saying exactly the same thing. We're just writing it in a different way. And the reason why I'm doing this is because you guys will see it in all of these different versions. So how did I get from here to here? Well, if I divide both sides, so if I say 1 kilogram divided by 1,000, and I divide that side by 1,000 because that's legal in math, the 1,000 cancels out and we're left with a 1, and the 1 divided by 1,000 is going to give me 0.001. So this right here, the 1 over 1,000, gives you 0.001. And I just flipped it around so the 1 gram was on the left and the 0.001 gram was on the right-hand side. And that's totally legal in math too. Okay, so there are other versions of this also. We could also say that we've got 1 gram per every 0.001 kilogram. That's writing this right here in a different style. Or we could flip that upside down. For every 0.001 kilograms, we've got 1 gram. Right? Or what we can also do is we can say for every 1 gram, we've got 1 times 10 to the negative third kilograms. Or we could flip that upside down. We can say for every 1 times 10 to the negative 3 kilograms, we've got 1 gram. You could also do that with what we had written up here. We can say that there are 1,000 grams for every 1 kilogram, or 1 kilogram per every 1,000 grams. And if you wanted to write that in scientific notation, you could do that also. So 1,000 is the same as 1 times 10 to the third grams per every 1 kilogram. Or per every 1 kilogram, you have 1 times 10 to the third grams. Now, the format that most students prefer will be this one right here, because 1 and 1,000, that's really easy to work with. Most of us don't like decimals and would prefer not to have to put things in scientific notation. But I want you to be cognizant over the fact that you're going to see all of those different versions, and you're going to need to know that they're saying the same thing. Okay, so let's go smaller. So give me a second to erase this stuff. And let's go down into milli. Okay, let's switch over to green. There we go. Okay, so let's do gram, and instead of milliliter, let's do milligram. So we can relate, oops, not gram. So we can relate gram to milligram. Now, if we have our base unit here, again, we're looking at the size. So the size of the milligram compared to the gram, or we could do milliliter compared to liter. What is this saying here? Well, it's saying that 1 gram is 1,000 times bigger than a milligram. What we could also say is that 1 milligram is 1,000 times smaller than 1 gram. Okay, so that's what this chart, the size part of it, is telling you. So let's make some equivalence statements. So if 1 gram is 1,000 times bigger than a milligram, how many milligrams can you fit in this 1 gram? You can fit 1,000 milligrams into a gram because the gram is 1,000 times larger than the milligram. Okay, so how we can also say that statement is 1 gram is equal to 1 times 10 to the how much? 10 to the third milligrams. All right, how we can also say these statements is you've got 1 gram per every 1,000 milligrams. Or you can flip that upside down and it's saying exactly the same thing. For every 1,000 milligrams, you've got 1 gram, or 1,000 milligrams per gram, or 1 gram per every 1,000 milligrams. How we would write this one right here as a ratio is the same way. 1 gram, and we have 1 times 10 to the third milligrams, because 1 times 10 to the third is exactly the same as what? It's exactly the same as 1,000. You're just writing it a different way. Or we could flip that upside down and put 1 times 10 to the third milligrams, because that's 1,000 milligrams, per every 1 gram. A million different ways to write this, but you guys need to be familiar with what it looks like. And all these things are saying exactly the same thing. Okay, so let's switch this around a little bit. Let us divide both sides of this equation by 1,000, because that's legal to do in math. And that is going to give us 1 milligram on this side, and that is going to give us 0.001 grams on that side. And that should look familiar because that is right there. Okay, so this is saying that if you have 1 milligram, it is this tiny little portion of a gram. Okay, if you have 0.001 gram, that little tiny portion of a gram, you have 1 milligram. We can switch this around and say 1 milligram is equal to this tiny portion of a gram, 0.001. Both of those statements are exactly the same. We can write it like this. 1 milligram is equal to 1 times 10 to the what? We're doing scientific notation here. How do you write 0.001 in scientific notation? You have -3 grams, and you'll see that right here. Okay, so you will also see it written like this. For every 1 milligram, you've got 0.001 grams. Or you can flip that upside down and say if you've got 0.001 of a gram, that's 1 milligram. Or you can write for 1 milligram, you've got 1 times 10 to the negative third gram. Or what else, you guys? Flip it upside down and say if you've got 1 times 10 to the negative third gram, that's a milligram, okay? So all the different versions of what you will see here. Most students prefer to do the positive version and not do its scientific notation. So most students like to say, for every 1 gram, you've got 1,000 milligrams. So 1 gram per 1,000 milligrams, or 1,000 milligrams per every 1 gram. Okay, that's just fine and dandy. Now the other ones, like giga, mega, hecto, deca, and then down here, centi, we've done milli, micro, nano, and pico. We will practice those. So if you look at their symbols, you might notice that there's a strange one right there. For micro, that is a Greek letter mu, and it looks like a U with a funny front leg. And yep, that's what that is. And we'll use that one. Okay. Here is a handy dandy little picture showing you how to memorize the different prefixes. So King Henry doesn't usually drink chocolate milk. It's showing you kilo, hecto, deca, and then just your base unit there. And deci, centi, milli. And that is kilo through milli right there. We don't use hecto or deca very often, but they're there if you want to use them. Okay, that brings us to something very important called dimensional analysis. We went through all of that chart right there in the million different ways that you could write a relationship between different units in the metric system in order to build up to dimensional analysis. So all of the stuff that I just went through, we will definitely use. And we'll use it for the rest of the semester. So dimensional analysis means using units to guide you through a problem to get to the answer in the unit that you need it to be in. So say you start with kilometers, but you need micrometers. So we will use dimensional analysis to get us there. And we're going to figure out which unit we want to start with and which one we need to get to. And we're going to use relationships between the two units. And we just went over the relationship between units to guide us to our answer. So what am I talking about? Well, equivalence statements, like we just did, we do in real life all the time. We say, okay, if I have 12 eggs, I've got a dozen. And that is how you would write it mathematically. The other way that you guys could write it mathematically is to say 12 eggs per 1 dozen, or 1 dozen eggs per every 12 eggs, or 1 dozen per 12 eggs, if you don't want to write that right there. Okay, so this is a bunch of different ways that we can write mathematically that if you've got 12 eggs, you've got a dozen. Okay, now how we use these equivalence statements is below. We set them up in a mathematical equation and we start with what we're given. So say you have 2 dozen eggs. And your brain will do this dimensional analysis right away. Your brain goes, I've got 2 dozen eggs. I know there's 12 eggs per every dozen. So 2 times 12 gives me 24. But if we were to set this up the dimensional analysis way, we'd start with our given. And then we would write in an equivalence statement that allows us to get rid of the unit we want to get rid of. So we want to get out of dozen eggs here, or just dozen, and we want to get to individual eggs. Okay, so whatever you have on the top here that you want to get rid of, you're going to put it in the bottom here. And what you need to get to, you're going to put in the top there. And this is called the conversion factor. The conversion factor is an equivalence statement that allows you to move to the unit you want to get to. So we know that we have 12 eggs per 1 dozen eggs. And we put 1 dozen eggs on the bottom here, because dozen eggs on the top divided by dozen eggs on the bottom there gives us what? Gives us 1, because anything divided by itself is equal to 1. So 3 divided by 3 is 1. 67 divided by 67 is 1. 12 divided by 12 is 1. Car divided by car is equal to what? 1. And dozen eggs divided by dozen eggs is also 1. Now don't forget that right here, the denominator is 1. We just don't see it when the denominator is 1, because that's another one of those things where we don't draw the 1 in when we don't need it. So we have dozen eggs in the numerator and dozen eggs in the denominator. So that's dozen eggs divided by dozen eggs, so that gives us 1. So we're left with 2 times 12 eggs, and the 2 times 12 gives us 24, and the eggs just becomes eggs, okay? And your brain does that automatically, but your brain's not going to automatically do some of the problems that we're going to have to go through. So that's why I took so long to go over this with you, because I want you to do well, okay? So again, what we do is we have the given unit here, like eggs or kilometers or liters, and we find a conversion factor that's an equivalence statement, where we have the given unit. So say our given unit was kilometers. We have kilometers down here, and we have the desired unit up here. So maybe we want to go from kilometers to meters. And then we're going to get a numerical answer plus the desired unit, which was meters. So we did that here. So what we're doing with our conversion factor is we are actually just multiplying our given by 1, because our conversion factor will be equal to 1. So we're not changing anything illegally, mathematics-wise. We're just changing the unit. Okay, so that was a lot of blah, 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 blah. So let's actually do some of these problems. So the first problem says that we've got green light that has a wavelength of approximately 550 nanometers. And we want to know what this is in meters and picometers and kilometers. So get your calculator out. I've got mine out right here. And before we talk about that, let's just take a look at the electromagnetic spectrum in case you've never seen it before, okay? So what we have in the electromagnetic spectrum is highly energetic regions over here, like gamma rays and x-rays, and low energy regions like radio waves, like in radar, TV, FM, AM, those really long waves over there. And what we have in the middle here, right next to ultraviolet, is our visible region, which is really tiny, the amount of light that we actually see with our eyeballs, and expanded, it's down here. Now, visible light, we tend to report these wavelengths in nanometers. And a wavelength is the distance between one peak to another peak. So that distance right there is a certain length, and that's called the wavelength. And this is a really funny looking Greek symbol right there, and it looks like a bent over H. Really strange. Okay, so we've got that there, or we could do one trough to the next trough. And we've got the wavelength there too. Okay, so there we've got our Greek letter for that. Now, what you'll notice over by the radio waves is those waves are super long. So look, the wavelength for a radio wave, the peak to peak, is 1 meter long. That's a big old long wave, okay? Now gamma rays over here, we've got 0.001 nanometers, and that's a really small wavelength. So we have a high frequency over in this zone, very energetic, okay? So that's what that looks like, and that's what we're talking about when we say that our green light is about 550 nanometers. It's right there. Now, notice how red light has a longer wavelength than the violet light over there. And if we wanted to take a look at this, we could see that the red light has a longer wavelength than the blue light down there. And you guys can see that on this chart right here also. Okay, so there's just a couple of different ways of looking at it. All right, so going back to the problem right here, now that we've taken a look at the electromagnetic spectrum and we know what we're talking about. So green light has a wavelength of approximately 550 nanometers, and we want to know what this value is in meters. So what we're going to write down first with our pencil is the given. We are given this value right here, 550 nanometers. This is our given. Now, if you need to visualize the fact that 550 is in the numerator and you've got a denominator there, you can go ahead and write the 1 on the bottom. You don't need to do that, but some people do. And now we want to get away from nanometers and we want to get to meters. So in order to get rid of nanometers, we're going to want to put it in the denominator here, because that means we're going to have nanometers in the numerator and nanometers in the denominator, and nanometers divided by nanometers is what? It's 1. So we're just multiplying by 1 in order to get from one unit to another unit. Okay, so we're going to want to put meters on the top because that's where we're going. And this right here, my friends, is a conversion factor. Okay, now what's usually easiest for most students is to think that a meter is a lot bigger than a nanometer. A nanometer is tiny. So we can put 1 meter right there and then think about how many nanometers can we fit inside that meter, and it's going to be a whole lot. So we go back to our chart back here. And what we'll notice is that we have this number right here. And we might be tempted to do 1 meter and then 1 times 10 to the negative 9th nanometer, but that's not how that works, because you got to think about this. Like, this is a really small number. Can you get a lot of nanometers into a meter, or can you only get a few nanometers into a meter? You can get a lot of nanometers into a meter. So in 1 meter, what you have is 1 times 10 to the positive 9, okay? Because this is the size of 1 nanometer compared to a meter. But if you've got a whole meter, you're going to have a ton of nanometers that you can squish in there. Okay, Now, if you wanted to go with 1 times 10 to the negative ninth, what you would have to say is if you had 1 nanometer, that tiny little bit, that is this tiny little portion of a meter. It's that small part of a meter, okay? Most of us like the positive exponents and like this version, but you need to say out loud to yourself what you're doing and make sure it makes sense. Because it doesn't make sense that this huge thing, this big meter, is exactly equal to this tiny little portion of a nanometer. That doesn't make sense. It makes more sense that in 1 meter, which is big, you can get a ton. 1 times 10 to the ninth is a very large number of nanometers. And we're going to go with this version because most of us like the positive versions. And this is just going to take practice. This is going to take working these problems over and over and over again, and you will get it, I promise. Okay, so 1 times 10 to the ninth. And we want to know what this equals. Now, with my calculator, I'm going to get 0 point, and I've got 6 zeros here to the right of the decimal. 5 meters. But how on earth did I get that? Well, I'm going to show you with the calculator to the right. So what I would type in is 550, and then I would do the division button, which is right there. And then what you want to do is 1, and that's that right there. And then you're going to hit the second key, which is up there. So we're going to do, and right now we're trying to do this times 10 to the ninth. So 1, and then hit the second key. And what the second key does is it allows you to go above. It allows you to go to the top of your button. And what we're looking for is the little EE portion above your x to the -1 button. So we'll do second, and then the key that you'll hit is the x to the -1. And what we're after is the EE portion of it, because the EE part of it, that is the same as saying times 10 to the something. And then we're going to hit 9. And then we're going to hit the equals button. And then that is going to give you guys this number right here, okay? So you need to take your calculator out on a date and get to know your calculator and how to solve these problems with your calculator, because it will be very easy to make a mistake and end up with an answer that looks very similar, but it's wrong. Something like 0.0055, or maybe 7 zeros or 8 zeros instead of the 6 zeros that are right there. Okay. Now, can you do this a different way on your calculator? Absolutely. Absolutely. This is just the way that I do it and the way that I know how to show you to do it. Now, if we wanted to get to scientific notation, so if instead of saying 0.6 zeros and then 5 meters, we wanted to say 5.5 times 10 to the -7 meters, which is the same thing, what we would do with this answer right here is we would then hit the second key, which is again right here. And what we're after is we're after the psi eng above the DRG. So then we're going to hit the DRG button because we want the psi eng. And then what you guys are going to do is you're going to hit the arrow to the right button right here, because what you'll see is you'll see flow, psi, eng, and I hope you're doing this with me, and it'll be at first on flow, and then once you hit the arrow, it'll move over to psi, and that's scientific notation. And then you guys will hit equals at that point, and then it'll give you this answer right here. And I need you guys to practice that over and over and over again. Now, I also need to say that we could do this in a different setup. So you guys could do 550 nanometers times, for every 1 nanometer, you have this tiny portion of a meter. Okay, you could also write it that way. So get used to how to work that, but say it out loud and make sure it makes sense. Okay, right here we're saying for every 1 meter, which is a very large thing, you can stuff 1 times 10 to the 9 nanometers in there. And that makes sense because you have a ton of little nanometers going into a meter. This one also makes sense because you're saying you have 1 nanometer, and that's a very, very, very tiny portion of a meter. So if you have 1 times 10 to the 9th, which is a small number, that portion of a meter, you have 1 nanometer, okay? And that's going to give you the same answers that we had above. All right, we're not done with this problem. So we want to do picometers. So let me switch back to blue for picometers. And what we're going to do is we're going to go with the given again. So we've got 550 nanometers, and we need to get out of nanometers. Now, if you need to put 1 down here, that's fine. And we're going to need to use what to get out of nanometers? A conversion factor. Now, most of us don't know how to go directly from nanometers to picometers. So what I'm going to ask you guys to do is go through your base unit. And your base unit here is meters. So we're just going to repeat what we did up here in order to get ourselves to meters, so then we can then go to picometers. So we're going to do the 1 times 10 to the 9th nanometers per every 1 meter. And again, you could use that version if your brain likes that version better. And now we have nanometers divided by nanometers, which is what? Which is 1. So we are now in meters. And if we are in meters, we can convert to picometers. So now I have conversion factor number 2. And I want to get out of meters and go to picometers. So do I put meters in the top or the bottom of my new conversion factor? I put it in the bottom. So now I have meters divided by meters, which is what? Which is 1, so I've gotten rid of it, and I want to go to picometers. Now, picometers is the smaller unit, so I suggest that you put the 1 next to the bigger unit and figure out how many of the smaller units, the picometers, you can fit into that meter. So it's going to be a very large number of picometers that you can squish into a meter. 1 times 10 to the what? And we're going to look back here at this chart. And we're going to go, okay, picometers is at the bottom here. It's extremely small. And we're going to see, oops, not times 10 to the 9th, times 10 to the negative 12th right there. And we're going to say to ourselves, okay, this chart is telling me that the picometer is super small. It's that little tiny portion of the meter. This is not telling me how many picometers I can get in a meter. If I want to know how many picometers I can get in the meter, I want to change the sign here. So you can get 10 to the positive 12th picometers in 1 meter. If you're asking about the size, a picometer is 1 times 10 to the 12th of a meter. Okay, so watch what you're doing, you guys. Okay, so we're going back here, and we're going to do 1 times 10 to the 12th picometers per every 1 meter. And say it out loud and see if that makes sense. Your meter is your bigger unit. So does it make sense that you can squish 1 times 10 to the 12th, which is a lot, of picometers into the meter, seeing as how the picometers are tiny? Yes, that makes sense. Okay. Now, if you wanted to write it the other way because you just like negative numbers, you could say that 1 picometer, which is tiny, is equal to this tiny portion of a meter. Okay, that's the same thing. You could use that version too. It will make your calculation correct. Okay, so we cancel out our meters because meters divided by meters is what? Is 1. And we want to get an answer here. So what we would do to find this answer is we would type in 550 on our calculator, and we do the divided by button. So that is right there. And then we want to divide it by 1 times 10 to the 9th. So we'll type in 1, and then in order to get times 10 to the, we're going to do second, and then we're going to hit x to the negative 1 because what we're after is the EE. Because again, the EE means times 10 to the, and then we'll hit 9 because the 9 is right there. Okay. And at that point, what I usually do is I usually hit the equals sign because I just like to hit equals a lot as I go, okay? So that's going to give you a value right there. And you're not going to need to retype the value in at all because you're going to get the value right there. And then whatever the answer says, and the answer will say 5.5 times 10 to the negative 7. That's on the screen. Don't need to retype that in. It's already there. What you'll do is then you'll want to multiply it by this value. So what you'll do is you will hit the multiply key, which is right there. And then you will hit, we're saying times 1 times 10 to the 12th, and then you will hit the equals key, and then your final answer is going to be 5.5 times 10 to the 5th, and we don't want to forget our unit because we want all of our points, and that's going to be picometers. Now, if you want to see this in standard form, what you guys would do is you would hit second, DRG, and again what you're looking for is psi eng, and then you would hit the key backwards like that because what you'll see is flow, psi eng, and if we're already in scientific notation, you want to go back to flow, and then you're going to hit the equals, and then it's going to give you 55000, and you'll have picometers. Okay, so that is how to do a lot of dimensional analysis and how to work the calculator together, but we aren't done with this problem. No. Okay, so back up here, look, it says we also need to do it in kilometers. Okay, let me erase some of this stuff right here so we can go ahead and do the kilometers. Okay, so again, we're going to start with our given. So we have 550 nanometers, and if you need to put over 1, put over 1. And we need to get rid of nanometers and go to kilometers, but most of us don't know how to go from nanometers to kilometers directly, so we're going to need to go through what? We're going to need to go through our base unit meters. So we're going to want to put nanometers on the bottom here in order to get rid of it, and meters on the top because that's where we're going. Now, who's the bigger unit, meters or nanometers? Meters. Meters is the bigger unit. So we need to figure out how many nanometers we can shove into our meter. And good thing we already did this. We already did this figuring out in our previous problems. We can fit 1 times 10 to the 9th, which is a huge number of nanometers, into our meter. Yes, you can write it the other way where you have 1 times 10 to the negative 9th meter divided by 1 nanometer, but most of us like the positive version better. Again, feel free to do that. So we have nanometer divided by nanometer, which is what? Which is 1. And we are in meters, but we're not done. We need to get to kilometers. So I need to get rid of meters. Do I put it in the numerator or the denominator in my second conversion factor? So this is conversion factor number 1, conversion factor number 2, and this is our given. What I'm going to do is put it in the denominator because I want meters divided by meters, which gives us what? 1, and I'm going to put kilometers in the top. Which is bigger, kilometers or meters? Kilometers. So it tends to be easiest for most people's brains to say, okay, let me put the 1 next to the bigger unit and figure out how many of the smaller unit I can fit into the bigger unit. Now, at this point, you should know that you can get 1,000 meters into a kilometer because that's just how it works. You could also write 1 times 10 to the 3rd on the bottom instead of 1,000 because that's the same thing. Or you could use the decimal version, the 0.001 kilometer on the top and the 1 meter on the bottom. Or 0.001 is the same thing as 1 times 10 to the negative 3rd. You could put that on the top and the 1 on the bottom. But for most of us, this version right here is where it's at. Okay, so we get rid of the meters because meters divided by meters is what? Is 1. And then we have to work with our calculator. So what we'll do is we would do 550 divided by 1, and then you would hit the second key, and then you would hit x to the negative 1 because what we're after is EE because we want to do 1 to the 9th. Okay? And at that point, I usually hit the equals, and it'll give you an answer on the screen. And then what I would do is then do divided by 1,000 and hit the equals key again because I don't know why I just like to hit the equals a bunch of times. And what we would get is a 5.5 times 10 to the negative 10, and we don't want to forget our unit because we want all our points. Kilometers. Okay, that was a lesson in how to use your calculator. So this week you're going to go over to Del Taco, order macho-sized fries, well done, extra salty. Take your calculator on a date, get to know it, so when you go to do quizzes and take a test, you're going to get the correct answer, right? Right. Okay, so let's do some problems. So your neighbor lost 50 pounds. How many kilograms did she lose? How many micrograms? So we're going from imperial to metric here. So we're going to write 50 pounds because that is our given. And we need to get rid of pounds, and we need to get to kilograms. So first of all, we're going to write pounds or pound, same thing, on the top or the bottom of our conversion factor. Which one? On the bottom, because we want pound divided by pound. And yes, pound is LB. The reason is Latin. Okay, and we want kilogram on the top. Now, do we know a relationship between pounds and kilograms? Well, if we look back here, way back here, what we have right here is for every 1 kilogram, we have 2.205 or 2.21 pounds. So we've got 2.21 pounds for every 1 kilogram. So that's not too bad. We do the multiplication on that, and we're going to get about 2.3 kilograms. Now, those of you who know how to do significant digits, don't worry at this point. Just let this one go. We'll do correct significant digits once we've had the significant digit lesson. Okay, so don't worry about that 0 on the 50. For the rest of you who are like, what on earth is a significant digit? Don't worry about it. We will get there. Okay, so we have 2.3 kilograms. Now, the second part of the question asked us for micrograms, so we have to do that one. And we're going to start with the same given. And we could go through kilograms into grams, or we could go, wait a minute, back on that chart, we had a relationship between pounds and grams, so we might want to use that. And that was right here. For every 1 pound, we have about 454 grams. Okay, so we've got rid of our pounds. Now, we're not where we want to be. We're in grams. We're going through the base unit, and now we need to go to micrograms. So we're going to get rid of grams by putting it in the top or the bottom of our second conversion factor. Which one? In the bottom, because grams divided by grams is what? It's 1. And now we want micrograms in the top. So we want that strange letter mu in the top, and we want grams in the bottom, and we want to figure out what the ratio of grams to micrograms is. Now, which one is a larger unit? Grams is a larger unit, so you can get a lot of micrograms into your grams. So let's figure out how many micrograms we can get in there. So going back to our chart here, micro right there, this -6 is saying that 1 times -6, that's that tiny little portion of a meter. So if you have a microgram, it is this tiny portion of a gram. So you can fit a whole lot of those tiny little micrograms into a gram. And how do I figure out how many micrograms I can get in a gram? Well, I just switch the sign on that exponent there. So we have 1 times 10 to the 6 micrograms for every 1 gram. Or what I could also say is 1 microgram is this tiny portion of a gram. But I think most of us are going to want to go with that version, the positive version. Okay? So 1 times 10 to the 6th microgram per every 1 gram. So our grams cancel out, and we're going to put this into our calculator, And what we're going to get is 2.27 times 10 to the 10th microgram. Okay, now again, those of you who know how to do significant digits, don't worry about the significant digits till we get there, right? Now, number 3 says how many milliseconds in a year? So what is our given? It's year. It's asking for milliseconds, so that's not our given. So we go ahead and we start with year. Okay, so that's our given there, and now we're going to need a conversion factor to somehow get to milliseconds. So what you guys can do is just start throwing equivalent statements out there. So for every 1 year, what do you have? Most of us will say 365 days. So day and days is the same thing. Some of you might have said 52 weeks. That's fine too. And then in 1 day, you're going to have what? 24 hours. Okay. And so that's an equivalent statement too. So again, you're just multiplying by 1 over 1 and 1 over 1. It works that way. Now, we've canceled out year and day, and now we want to cancel out hours. So does hours go in the top or the bottom? Goes in the bottom. And we want to get smaller. So what are we going to go to? We're going to go to minutes. So in 1 hour, you have how many minutes? 60. And we've canceled out our hours. And now we want to get rid of minutes because we want to get to milliseconds. So we want to put minutes in the top or the bottom? In the bottom. And we want to go to what in the top? Seconds. And seconds is S, not SEC. So remember that. So for every 1 minute, you're going to have 60 seconds. And some people know how to go directly from hour to seconds. They're like, oh, in 1 hour, there's 3,600 seconds. Yep. If you want to combine these two conversion factors, go right ahead, my friends. So minutes cancel out, and now we're in seconds. And we want to get rid of seconds, and we want to get to milliseconds. Now, which one's the bigger unit? Milliseconds or seconds? Seconds. So we're going to want to put a 1 there. Now, how do we figure out how many milliseconds in a second? Well, if you have 1 gram, you're going to have 1,000 milligrams. And if you have 1 liter, you're going to have 1,000 milliliters. So if you have 1 second, how many milliseconds do you have? 1,000. See, the metric system is awesome that way. Okay, so we cancel out seconds, and now we're in milliseconds. And you do all of the multiplication, and you should end up with 3.15 times 10 to the 10 milliseconds. Now, you guys, if I ever do the math wrong, please email me and let me know. Occasionally, I type in something wrong on my calculator. I try to be correct. But if you don't let me know, I don't know to correct it. Oh, one thing also, back here, I think I failed to say that this Greek letter is called lambda. Sorry about that. That is lambda. So we've seen mu and we've seen lambda so far. Gamma is this funky looking Y. That's another Greek letter. And that, my friends, brings us to the end of dimensional analysis. So I will see you again for the significant digit lecture. Bye-bye.